Hello and welcome to today's video. In today's video, I'm going to show you how we can take your human readable JSON save file and encrypt it into something that's just not readable at all. So you can see here that we've got our inventory system with some inventory slots, and we've got an item ID and stack size. If a player wanted to, and this was the way their save file was, if this was an item of mega healing potion and they had one of them in their save file, they could just put a few more zeros on, hit save, and then when they loaded that data up, they'd have 100 mega healing potions. And that's fine if you don't mind that. Single player game, let people modify it if they want to cheat. That's how I'll probably do things going forward. I'm not gonna, I don't necessarily feel there's a need for encryption, but certain people do. You might not want to be able to hack your game that easily. So there is a very simple method to garble it all up and encrypt it into a version that's just not readable at all. And now this isn't the safest form of encryption. It requires a hard-coded keyword in the file. So if someone finds the keyword, then they could write a program or use some sort of converter using that keyword to unscramble the data. But that's going to be, if they're going to go to that length to cheat, why not let them? And again, especially if it's a single player game, does it really matter? And if you had an online game, you probably wouldn't be storing their save data in JSON anyway on locally. Their data would be on a server or something like that. So let's just quickly show you how to do this. And if you want to learn more about saving and loading, I do have a video on save loading, and we use that save system in the inventory tutorial system. And this is the inventory tutorial project that I'm in now. So you can see here, we've got a private static read-only string keyword, and it's just a bunch of random numbers. And the way I generated that was if you go over to Google and you just type in random number generator, right at the top, it gives you a random number generator. And all I did was put 1 and then a load of zeros, copy and paste it in, put 9 and a load of zeros, generate. There we go. We've got a new keyword. So I just copy that and then paste that as your string here. You could have a word if you wanted to. It doesn't have to be a bunch of random numbers. This could be subscribe to Dan Poss if you wanted to. And if you do want to subscribe, down below. But I'm just going to keep it as this random number. If someone is looking into the files and decompiling your game, you might not want to call this keyword. Maybe you want it to call that something random as well, just to make it less obvious as what it is. But having a random number just means that, it's not going to be as obvious that it is what it is. So in our save function, I've just got a bool here, and we've got encrypt data. And this is reading a static bool on our save game manager, which we can control with the tick box in the inspector. And we'll go into that in a second. So dependent on whether we want to encrypt our data or not, we're going to do some things. So we've got our JSON utility, and we're making our data, we're turning our data into a string of JSON data. And again, if you want to learn more about how I've set up the save system, click the card and watch that video. So we're getting our JSON string, which we're going to save out. If we're not going to bother with encrypting, we're just going to write that string straight out into the file. But if we are going to encrypt it, we're going to run it through our encrypt and decrypt method, which I'll go on to in just a sec. But let's take a look at the load function. So we've got, again, it's the same bool, it needs decryption, and it's going to read that same value from the save game manager. So here I've made a new variable called JSON data, and it's a string, and we're just reading the text. So whether the JSON string has been encrypted or not, doesn't really matter. We're just going to read that text into this string here, this JSON data. That was just for debugging purposes. We can get rid of that. So then we're going to set data, which is our save game data. We're going to set that equal to the JSON utility from JSON, casting that to the save data class, and dependent on the variable, this bool, so it needs decryption. If it does need decrypting, then we're going to decrypt the JSON data, and this is going to return the unencrypted version. And if we're not going to decrypt, then we can just pass in the JSON data, which we've just got here. So let's just take a look at this encrypt and decrypt method. So we've got a private static string encrypt decrypt, and this is going to take in a string. So this is the data to encrypt. And all we're going to do is, let's just get this nice and big. So we've got our private static string encrypt decrypt. We're making a new string called result, and we're just setting this equal to an empty string. And then we're going to go into a loop, and we're going to loop through all of our data at the index that we're at. Remember, strings kind of under the hood are just char arrays. So that's why we can, check at an index, because a string is an array. So we're getting our result and we're appending to it letter at the data, and then we're using the XOR operator against our keyword. And again, our keyword is a string, so it works the same, it's an array. But because we don't know how long our keyword is, the actual length of it, we don't want to go out of bounds. We can't just put I in here because say our data was, 20 characters long and our keyword was only 10. As soon as this gets to index I equals 11, we're going to be out of range on our index and it'll throw an error, it won't work. So we use the modulo operator against the keyword.length, and this makes sure it just loops round. So if we go back to our calculator, so here on Google, if I go 5 modulo 20, you can see that our answer is 5. So say if our keyword was 20 characters long, we put in an index of 5 because that's where we were in the loop, we were at 5. But then we'd get the 5th index of our keyword, which is in range. If we then get up to our JSON save file string is 25 characters long and we're at index I equals 25. And again, our keyword is only 20. We're going to be out of range normally, but if we use the modulo operator, it's just going to go back to 5. So basically, this is just a way of looping around within an array to make sure that we are never out of range. So, this could be whatever, modulo 20, so this is going to be index 13. So that's all the modulo operator is doing. So once we found the characters that we want to compare against each other, we use the bitwise XOR operator. And if we look at the definition of what the XOR operator is, it's represented by that symbol that we've just used, and it performs bitwise XOR operation on the corresponding bits of 2 operands. If the corresponding bits are the same, the result is 0, and if the corresponding bits are different, the result is 1. So you can see here that taking the number 14 in binary would be 0001110, and 11 is 0001011. So using the bitwise operator, we can see that 0 and 1 are different. So the output will be 1 in the first column, 1 and 1 are the same. So 0 is placed into the next column, and then 1, 0 are different. So that's a 1, 1, 1 are the same. So that's a 0, 0, 0 are the same, and so on. So if we then take that bit of binary, that equals 5. So that gives us an output to cast back to a char, and we can add that to the string. And because of the way this works, it can be done in reverse, which allows us to decrypt our data as well. So if I just copy this example here into a new notepad. So here, this is our JSON saved data. This is our keyword. And this is 5 in decimal. This is the output. So let's just copy this down here. So now this is our scrambled data. Scrambled data. This is our keyword. So we're going to try and decrypt it, and we want to get JSON save data back, which you can see 0001110. So if we look at this first column, so 0 and 0 are the same. So when something's the same, it's a 0 in the corresponding column. So we can do all that because these 4 zeros and these 4 zeros are all the same. Then we get to this 0 and this number 1. So 0 and 1 are different. So that's a 1. 1 and 0 are different. That's a 1. 0 and 1 are different. So another 1. And then 1 and 1 are the same. So that's a 0. Now, if we copy our JSON save data, you can see that's the exact same number. So we've taken our scrambled data and we've put it back into our JSON save data. I hope that kind of makes sense. It's a bit confusing. I'm still not 100% sure, but this kind of working it out like this kind of helps me get my head around it. And that's all there is to it, apart from our save game manager. So if we go back up here, we can see this bool here. And because our save load class is static, we have to do a bit of jiggery pokery on our save game manager. So here I've got a public static bool, encrypt save file, and I'm just setting that to false by default. And then I've got a public bool use encryption, which is set to false by default. And then in on awake, I'm setting our static bool equal to our public bool here. So that allows us to change this in the inspector and then access it from the other script by putting it into a static version of that bool, because you can't set static bools in the inspector. So this is a bit of a workaround. So all we do here is on awake, we put our static bool equal to whatever we've set in the inspector, and then that's it, back on our save game. We've already been through it. We get that static bool and use that, so bool encrypt data. So that's it. I hope that was useful. If it was, let me know in the comments below. As always, you can get all my project files over on Patreon, which is patreon.com/danposs. If you've got any questions, concerns, ways I can improve this, anything I've done wrong, let me know in the comments. Or head over to the Discord server, which is linked in the description below. But in the meantime, thanks for watching, and I'll see you in the next one. Bye.